talked about this in previous class because I am giving example for mechatronics. Mechatronics is there where many places. This is one of the most popular one as a robot, industrial robot, which is there in many industries, including automotive. Because in the automotive industry, one which uses extensive use of robotics compared to any other industry, of course. And we are talking here about the robot. The robot as a mechanical structure made of joints and links. Already told. Each joint is controlled by an actuator, generally a motor. And if you activate the motor, the joint will work. As I told you, this link is connected to this link. I say that this is base link L0, this is L1, this is L2. This is link 1 and link 2 are connected by this joint. I say joint 2. And this is called base joint. This and L1 is connected by another joint, which is called M1 because it's inside. That is called J1 joint. I can say that joint 1. Joint 1 is powered by motor 1, joint 2 by this one. Wherever joints are there, you see the motors. We can see that there are motors starting from M1, M2, M3, M4, M5, M5. That means there are 6 joints starting from joint number J1, J2 to last joint I call J6. All are rotary joints. If I move my joint 1 with respect to base, this is the L0 link. They call base link. I can call as base link, which is grounded, connected to the bed of your robo. So that means L1 link cannot move. Correct? This is a fixed link. And with respect to, there is a joint here. That is what which is powered by this one. If this motor rotates, the entire robot rotates. Please see that any links, all these things will rotate 360 degree because joint is a rotary joint. Similarly, if the M2 rotates, this motor rotates, this link will rotate 360 degree. But there is a restriction. It cannot get restriction, it will go and hit. In that case, the remaining part of the robot will rotate clockwise anti-diagonal. Similarly, if the M3 rotates, right, then this part of the robot will rotate. But you can see the remaining part won't rotate. Right? So by rotating M1, M2, M3, M4, M5, M6, I can make the end effector to move in X, Y, Z. Correct? It is a Cartesian coordinates, 3-dimensional space. The end of here, if I attach a gripper, the gripper will move in the 3-dimensional space. Correct? It is a volume. In the volume, it can go this robot hand can go to anywhere. Right? Like this. But this can be extended like this. Further, it can be extended like this. Correct? So by moving different joint, I can make my end effector to go in the any. This is called a workspace or work volume. If it is 3-dimensional space, it will be work volume. If it is a planar robot, it is called work area. Correct? That means it can have X and Y, Z direction it cannot move. So depending upon you can do that. Already I told that how it works. So that means the whole thing is implemented using a controller. This can be a computer or ECU, electronic control unit, or a computer in which I put motion planning algorithm, all those things as programs. Right? I write in C, C++ or Python some coding. I can write all the algorithms. So the motor generate control signal. This is my control signal. The control signal goes to individual. Please note that this is control signal. Right? The control signal go to motor driver, which in turn drives the motor. Correct? This is actuator, nothing but motors. In robot, it is nothing but motors. Correct? The actuator can be a motor, or it can be electric motor or a servo motor. In the electric motor, you have different types: stepper motor, servo motor, or DC motor, or AC induction motor. Similarly, you can have hydraulic motor, pneumatic motor also. If you want more torque, all those things, the electric motor can be replaced by a hydraulic motor. Bigger robots where load carrying capacity, because I am going to carry some load here. I put a hook and load is there. If load is higher, I cannot use electric motor. Electric motor cannot produce high torque for given size. Hydraulic motor for the same size of the volume, The hydraulic motor can give more torque, so it can carry more load carrying capacity. You can use that. So this is called a functional block diagram, as I told you that, right? So in the exam, if you are talked about to give an example for mechatronics, you may be asked to write, because that's what the exam is going to be there, correct? So quiz 1 and some, quiz 2 everywhere, because we have midsum, we have midsum and endsum. So for example, draw the functional block diagram of the robot. I'm not going to ask you to draw this diagram neatly. You can write a line diagram. A line diagram is like this. So this is the base link. I call as this is ground. This is nothing but table, correct? Represented as a ground or table where the robo is attached, correct? This is this one. This is link 0, correct? So this is link 1. This is link 2. This is link 3. Here I have my end effector, correct? This is 3-degree freedom robot. Okay. Then we have already told you what it is a risk mechanism. I have a risk mechanism, right, on which the end effector is attached. Okay, here it is not shown. This is end effector, which is called a gripper. This is symbol for gripper or end effector. EF or gripper. Correct? This is my wrist mechanism. Wrist in the human hand, correct? That's why it's called wrist mechanism. This alone gives 3-degree freedom. Wrist mechanism has 3 joints having a common center. It is manufactured such that there are 3 motors. You can see that M4 to M, all these things are here. There are 3 motors attached, okay, which in turn is going to control this. So now this is what you have to draw. You can say that this is wrist mechanism with a 3-degree freedom, and this is an first joint, and this is connected to M1 motor. This is the second. I call this R1 rotary joint. This is the second joint. I call R2. This is connected to another motor, M2. This is my third motor, M3. This is R3. This is my wrist mechanism, which are 3-degree. There are 3 motors, M4, M5, M6. This is my end effector. So you can draw this. Then you need to draw this is a, you need not draw all these things. This is not needed, correct? This is called line sketch to explain, right? For understanding purpose, you draw that. Then this you have to draw. This is the control diagram, control functional diagram, control system functional diagram. What is so? This is mechanical. This is a mechatronics. This is a robo. This is controlled by an actuator. These are nothing but M1 to M6. Correct? This is my controller, embedded controller. ECU, electronic control unit. ECU, in which there's a microprocessor, which has a microprocessor plus memory plus other electronics. We call a whole thing is called a hardware. Correct? In computer, you have 2 things. What you are seeing, a motherboard, all those things are called as hardware, power supply, which is put inside this one, and on which you install software or run software. Correct? Install software. Correct? So that is nothing but this. The motion planning trajectory director, which will make the motor to make the control to generate control signal to individual motor. So the green color lines are nothing but final voltage or control signal applied to motor. Actuator. So when the actuator, the motor rotates, individual joint rotates, automatically the end effector rotates. So the job of the robot is to move the gripper, which is going holding an object from location X0, Y0 to Z0 to new location. For example, like this. Correct? I say X1, Y1, Z1 in 3-dimensional space. So I am moving the end effector from this location to this location. Correct? This is called a path. Correct? To move the path, I have to move the joints. Okay, I have to vary the joints. So each joint, see the motor rotates, that means the 3-dimensional. So joint variable called theta 1, theta 2, theta 3, theta 4, theta 5 and theta 6. Okay. If I move M1 motor, the theta will vary from 0 to 360 degree. Correct. This also varies 0 to 360 degree. Similarly, all these things can vary from 0 to being theta is because you know that one circular rotation takes 360. So if I vary this 0 to 360,